Hello viewers, good morning, good afternoon, good evening, depending on when you're seeing this video. In today's class, we're going to look at simultaneous linear equations with three unknown, that's with three variables. The first thing you're going to do is to identify two equations that you can make the variables of any of the variables to have the same coefficient, and then you eliminate that variable. From the first and second equation, if you look at equation 1 and 2, the coefficient of z here is 2, but the coefficient here is 1. It means that if you multiply the first equation with 2, the coefficient of z will be the same in both equations. So we can start by saying equation 1, which is I, multiplied by 2. Let's see what we have. 2 times 3x will give us 6x, plus 2 times 2y will give us 4y, minus 2 times z will give us 2z, equals 2 times 19 will give us 38. All right? So let's proceed. From this point 2, we can say we can bring down equation 2, which is 4x minus y plus 2z equals 4. All right? So we solve these two equations simultaneously. Since the coefficient is the same, we want to eliminate this. We're going to add a sign that will enable the elimination. Let's say plus. 6x plus 4x will give us 10x plus 4y plus minus y. Plus minus is negative, so 4y minus y will give us plus 3y. Negative 2z plus 2z is 0, so I'm not going to write anything on z. Z has gone away. 38 plus 4 will give us 42. All right? So this equation, I'm going to name it equation equation V, which is 4. Okay, so we're also going to identify another pair of equations, two equations that the different ones that we can also eliminate z. So we can say equation 1 and 3. Now, if you look at the coefficient of z in equation 1, it is 1, and the coefficient in equation 3 is 5. So it means that if we multiply equation 1 by 5, the coefficient will be the same, so we can eliminate. So we also say equation 1 multiplied by 5. All right? Okay, so what will it give us? 5 times 3x will give us 15x, plus 5 times 2y will give us 10y, plus or minus 5 times z will give us negative 5z, equals 5 times 19 will give us 95. All right? So now we're going to bring down equation 3 to solve simultaneously with this equation. So equation 3 says 2x plus 4y minus 5z equals 32. Okay? So we also do this line and then get the resultant equation. For us to eliminate 5z, we have to add a sign that will enable it, and that sign is negative. I will tell you why I won't get there. Negative 15x minus 2, 15x minus 2x will give us 13x. 10y minus 4y will give us plus 6y. Negative 5z minus minus is plus. So negative 5z plus 5z is 0. I'm going to leave the space for z vacant. Then 95 minus 32 will give us 63. Okay? All right, so we proceed. This equation, we're going to name it equation, this is equation IV. So this equation is going to be equation V. This equation will be equation V. All right. So now we're going to solve, we want to attempt solving equation IV and equation V simultaneously. How do we do it? We want to make the coefficient of y in equation IV to be the same with the coefficient of y in equation z in equation V. So what we do is we say IV, that's equation IV, multiplied by to make y the same, we'll multiply by 2. So this will give us 2 times 10 will give us 20x, plus 2 times 3y will give us 6y, equals 2 times 42 will give us 84. All right. So we bring them down this way, and then we put our negative. Okay. Now 13x minus 20x will give us 7 negative 7x. 6y minus 6y is 0, so y is gone, equals now 63 minus 84 will give us negative 21. Negative 21. So the implication is that negative 7x divided by 7 is equal to negative 21 divided by 7. Sorry, divided by negative 7. And this will give us 1. And this will give us 3. Therefore, x equals 3. Okay? Now we're going to substitute 3 for x into any of the equation that only has x and y. All right, so let's substitute it into equation IV. So substitute 3 for x in equation IV. All right, so IV says 10x plus 3y is equal to 42. So anywhere I see x, I replace it with 3, which means 10 into 3 plus 3y is equal to 42. So this means that this implies that 10 into 3 will give us 10 times 3, which is 30, plus 3y is equal to 42. All right. So 3y will be equal to 42 minus 30, which implies that y will be equal to 42 minus 30 will give us 12, will be equal to 12 divided by 3, which means that y is equal to 4. All right. So we're going to substitute x and y into any of the original equations. So let's say substitute it into equation 1. We can say equation 1, which is I. Now it means that 3x plus 2y minus z is equal to 19. So 3 into 3, because x is 3, plus 2 into 4, because y is 4, minus z is equal to 19. All right. So this implies that 9 plus 8 minus z is equal to 19. So negative z will be equal to 19 minus 9 minus 8, which is equal to 19 minus 9 is 10, 10 minus 8 is 2. So z will be equal to, since we have negative z equals 2, so z will be equal to negative 2 if we multiply both sides by negative 1. All right, therefore, x equals 3, y equals 4, z equals negative 2. And this is the solution to our question. I hope this class was so interesting and fun. Please don't forget to like, comment, and share. And if you are watching from YouTube, please subscribe to our YouTube channel for more videos. Thank you and see you in my next video. Bye.